In this video, we'll be learning about the remainder theorem. To get started, let's remember how we divide using long division. So if I had a question like 753 divided by 22, and I didn't have a calculator, how could I figure this out using long division? Our method for long division looks something like this. You take the number we're dividing by, 22, and you write it beside 753 like this, with our little long division symbol. And then I go place value by place value. How many times will 22 divide evenly into 7? And the answer is none. So I don't write anything, but then I look at the next place value. How many times will 22 divide evenly into 75? I think I can divide 22 evenly into 75 3 times. And then I multiply. 3 times 22 is 66. And then I subtract 75 minus 66. My answer is 9. Then I bring down the number 3. And now I ask myself, how many times will 22 divide evenly into 93? Here my answer is 4 times. 4 times 22 is 88. 93 minus 88 leaves me with 5. I'm going to stop there because I found my answer. 753 divided by 22 is equal to 34 with a remainder of 5. So this number here, 5, is what we call the remainder. The other pieces of this question have math names as well. 34, our answer, is called the quotient. 22, what we're dividing by, is called the divisor. And 753, the number we started with, is called the dividend. So this is how we divide using long division. And what we're going to see is that we can also divide a polynomial by a binomial using this same method. So let's look at an example. Let's divide 3x squared plus 2x cubed plus 8x minus 12 by the binomial x minus 1. So the first thing I'm going to do is rewrite the polynomial in order of descending powers. So I'm going to rewrite this as 2x cubed minus 3x squared plus 8x minus 12. And I'm going to divide this by the binomial x minus 1. And now I ask myself, what do I need to multiply x by to get 2x cubed? So what do I multiply x by to get 2x cubed? I can multiply x by 2x squared. Notice how I line up terms that have the same degree. So if I multiply x by 2x squared, I get 2x cubed. And that's my next step. I'm going to take that 2x squared, multiply it by x to get 2x cubed. I'm also going to multiply 2x squared by negative 1 and I get negative 2x squared. So my third step to rewrite that, multiply the binomial x minus 1 by 2x squared. And then, just like in long division, I subtract and bring down the next term, which is 8x. So subtracting 2x cubed minus 2x cubed is 0. Negative 3x squared take away negative 2x squared would become negative 3x squared plus 2x squared. So I'm just left with a negative x squared. Bring down the 8x. And now I just repeat until I run out of terms to divide by. So what do I need to multiply x by to get negative x squared? Well, I can multiply it by negative x. Multiplying my binomial by negative x, I get negative x squared plus x. I'm going to subtract those. So the negative x squared, take away negative x squared, cancel each other out. 8x minus x gives me 7x. Bring down the 12, or the negative 12. What do I need to multiply x by to get 7x? The answer is positive 7. Multiply 7 by the binomial, and then subtract. And I'm left with negative 5. So just to summarize that, negative 3x squared plus 2x cubed plus 8x minus 12 divided by x minus 1 is equal to my answer, which was 2x squared minus x plus 7 plus a remainder of negative 5 over the divisor x minus 1. Or, to say this another way, when a polynomial p of x is divided by a binomial of the form x minus b, the result is p of x divided by x minus b is equal to q of x plus r over x minus b, where q of x represents our quotient, r is the remainder, and if I want to check to make sure that I've done the division properly, I could see if p of x is equal to x minus b times q of x plus the remainder. So if I cross multiply, bring that x minus b up, I end up with this statement, which can be used to check the division. Let's look at another example. Dividing 4x cubed plus 9x minus 12 by 2x plus 1. So I'm going to set this up the same way as my previous question. 2x plus 1, my division symbol, and then writing in order of descending power 4x cubed. Notice how there's no x squared term here? We need to represent that in the division by adding in a term of 0x squared. That represents a placeholder. Plus 9x minus 12. Then we follow the same pattern. What do I multiply 2x by to get 4x cubed? I can multiply it by 2x squared. 2x squared times 2x, 4x cubed. That's 2x squared. I subtract. I end up with negative 2x squared. Bring down the 9x. And do it again. What do I multiply 2x by to get negative 2x squared? I multiply it by negative x. Multiply again. And then subtract. 9 take away negative x. It's the same as 9 plus x. So I have 10x. Bring down the 12. What do I multiply 2x by to get 10x? I multiply it by 5. 5 times 2x is 10x. 5 times 1 is 5. Do my last subtraction. End up with a remainder of negative 17. So if I'm going to write the corresponding statement that can be used to check the division, I would say that 4x cubed plus 9x minus 12 is equal to 2x plus 1 times 2x squared minus x plus 5 minus my remainder of 17. So I could, if I wanted to, distribute this and simplify, and I should end up with my original polynomial. The restrictions on the variable are my divisor, 2x plus 1, can't equal 0. We can't divide by 0. Which means, if I rearrange this, 2x can't equal negative 1, or x can't equal negative 1/2. So this leads us to a theorem, the remainder theorem, that states that when we have a polynomial function divided by a binomial, the remainder will be the polynomial evaluated at b. And when we're dividing by a more complicated binomial, so ax minus b, the remainder would be the polynomial evaluated at b over a. We're just going to do part A here. Use the remainder theorem to determine the remainder when p of x is divided by x plus 1. So according to the remainder theorem, p of negative 1 should equal the remainder. So let's see what p of negative 1 is. So sub in negative 1 for all our x's. And I get negative 2 plus 1 plus 3 minus 6, or negative 8 plus 4, which is negative 4. So according to the remainder theorem, the remainder, if I was to do this division, should be negative 4. Let's check this to make sure the remainder theorem works. So let's take that polynomial and divide it by x plus 1. So what do I multiply x by to get 2x cubed? It'd be 2x squared. Multiply. And then subtract. End up with negative x squared. What do I multiply x by to get negative x squared? Negative x. Forgot to bring down that negative 3x. Bringing the negative x down, multiplying, and then subtracting. I have negative 2x left, bring down the negative 6. What do I multiply x by to get negative 2x? Negative 2. And subtracting, I get a remainder of negative 4, which agrees with what the remainder theorem told me. So the remainder theorem is just a way to determine the remainder of a polynomial when we divide it by a binomial without having to do the long division. And there's just a summary. We've seen how we can divide long division. We've seen how we can use long division to divide a polynomial by a binomial. And two big ideas from today: the statement of the division, a polynomial divided by a binomial is equal to the quotient plus the remainder over the divisor. And also the bigger idea, the remainder theorem, which we're going to use a lot in the coming days as we start to look at why we want to even be able to divide a polynomial by a binomial.